Hello and welcome to the demonstration of our to-do application TickFlow. Our development team include Anuradha Besinger as project owner, Ibn Deshani as Scrum Master, Visa Guran as developer, Himachal Suravida as developer, Shafi Mohasin as development engineer. All team members contributed equally to the success of this project. TickFlow is a simple yet effective task management tool. It supports user authentication, user and task CRUD operation, user states management, and search feature to help user manage their workflow efficiently. As a project owner, I was responsible for overseeing the project vision, aligning the team's effect and our goals, prioritizing the backlog, and ensuring we met our deliverables on time. For version control, we use Git, maintain a separate repository for the front end and back end. We followed a structured branching strategy to handle sprint releases, production, development environment. Every member was actively involved in Git file management. To manage our task and timeline effectively, we utilize the Trello as our task management board. Now let's move on to the Scrum Master part of the demonstration.
I'm Nipuni Deshani, who is the Scrum Master, and I facilitate sprint planning using Trello as our task management collaboration tool. We use Trello to visualize and manage the product backlog, plan our sprints, assign tasks, and track progress throughout the development cycle. I'm Nipuni Deshani. As you can see here, this is our product backlog. Now the development is complete, all tasks have moved to the done stage, indicating that each user story has been implemented, tested, and accepted according to the definition of done. Now the development is as the Scrum Master, I have defined the sprints. We followed short focus sprints with clearly defined goals, which help maintain momentum and ensure timely delivery. To support this, we held daily stand-up meetings using Microsoft Teams where the team shared updates, discussed blockers, and aligned on priorities for the day. This helped us stay on track and adapt quickly to any challenges. As a Scrum Master, I also encourage the team to apply agile engineering practices like test driven development and pair programming while ensuring that all work items met the definition of ready before entering a sprint.
In this project, I was mainly tasked with spearheading the front-end development of this project and integrating it to the CI/CD pipeline. In the first sprint, I spent majority of my time focusing on project initialization, and for that I used technologies like React JavaScript using Vite and Node and libraries like Tailwind and SUI for CSS. After initializing the project, I worked on setting the file structure and the routing of the application components. In addition to that, I worked on the UI you are seeing here, the login and sign up pages. Other than that, I also worked on the CI/CD part. We had to like change the S3 bucket into a EC2 instance, which will be discussed later on by another teammate. Moving on to the Sprint 2, I was able to integrate both login and sign up APIs. As you can see here, it's working fine. Then I worked on this navigation bar with the logout function and everything. And I also implemented the settings functions, which is also functional. And then behind the scenes, I also worked on auth context and access instance like functions. They are where it's handling the user sessions and API interactions and whatnot. So moving on to Sprint 3, I mainly worked on the homepage where it's displaying the user task like visually and whatnot. And also like I spent majority of my time doing version controlling and quality assurance in the sprint because majority of the project was done at this point.
Apart from the wireframe designing, I worked on the front-end development, mainly focusing on the task management section. So during the first sprint, I handled the developments in attacks functionality front-end, and I created a form like this to create and submit the tasks. So this is the code of the to create that form for the front-end. So during the first sprint, comes to the second sprint, I created a DTO for the task first, and then created a service to interfere with the backend API endpoints, and I created these codes to list and display the tasks from the backend. So with that, I created the UI like this, and here we can view the list of tasks available in here, and we can filter the tasks like this. with the tab items, and we can edit the tags like this. And also we can add a new task like this. We can fill the due date and time fields as well, and we can give up a priority level, and we can add the tags. So when it comes to the third sprint, I did some enhancement for the task management section by adding some nice looking icons in these places, and I added a search field like this. We can filter the tags from here, and added a progress bar to view like this also. So these are the branches I had throughout this tree sprint we had. So this branch is created to reverse some related changes with the merge happened mistakenly before. So this is how my contribution was happened throughout this project. And for each PR we have several commits like this.
For backend development, we have selected Node.js. Node.js is a JavaScript server-side runtime. When considering our application is segregated into four. One is the configurations. All the configuration related logic would be resided in the configuration. The middleware would be an global universal error handler, and also modules. Modules we have further broken down into three. One is the auth module, which has the authorization and authentication, and then the task module, and then the user module. The user module, all the specific logic would be related to users. When considering the development, I have undertaken the part of doing the sign up API development. In the sign up API development, if you are going to break it down, we intake the user details, and also we take the password. And this is the logic for hashing the password. For password hashing, we have used bcrypt. When considering the development, I have undertaken the part of doing this. So once the password is hashed, the hash password is saved in the database.
As a developer, I engage to the project development work by implement the code part relative to project user authentication. This is the user signing part in the controller class, and this is a service class. So this is a service I wrote. And not only that, I create the delete user part also. This is a controller class, and this is a repository class. And also this is the service I wrote for that, the delete operation regarding the user. So not only that again, so the task read operation, I created that one. This is the controller class, and this is the repository class, the code part, and this is a service I wrote for that.
In the task management module, I have undertaken of developing the creation of task. So same as previously, there is an incoming API call which will have the user details and the user ID. So when it received, it initially validates if it is a valid user, and then it proceeds with the saving with the database. So here it comes and it saves the user.
I have successfully implemented the update method for the user module, which allows user update their account details securely and efficiently. In the task management module, I have completed the core functionalities, including update and delete methods. These enhancements ensure that user can modify and remove tasks as needed, supporting better task organization and management.
For API testing, we have gone with Postman. Postman is a free tool. So whatever the development we did this one. So whatever the request response is done through Postman. So we organized all our APIs in this structure, and we collaborated this, and we shared this with our team. For API testing, we have gone with Postman. For the database, we have gone with MongoDB. MongoDB is an NoSQL database. We mainly selected this database due to schemaless development. So since this is a very rapid project, this was a very ideal database for us to go with. So this database would have two collections. One is the task, whatever the task being saved here, and the other one is the user. For the database, we have gone with MongoDB.
As a project owner, I reviewed merge request before they merge for the branches. I did it for the front end and also the back end. Not only that, I wrote user story, estimations, and prioritization report. As a project owner,
Apart from the development side, I also completed the supporting documentation and design materials to ensure everything is aligned with our project goals. This includes user stories clearly defined for each feature and acceptance criteria to validate that all functionalities meet user expectations, and wireframe diagrams to visualize the user interface and user experience, and test cases be written to validate each functionality under different scenarios, And finally, all this work well documented in the project wiki on GitHub for easy reference and collaboration. And also, I have made some pull requests after reviewing the code.
For continuous testing, we have used a Docker. What you see here is a Docker file of the Express application, and this is for the React application. This help us to isolate the two environments and test it locally without any conflicts. And also this help us integrate with the CI/CD pipeline, which made our deployment. We have used a Docker. What you see here is a Docker file of. For the server, we have selected AWS EC2 instance. We use Docker to deploy both the backend and the front end in this Ubuntu server. What you see here is the SSH of that Ubuntu server. For continuous deployment, we have selected Jenkins. What you see is the two services, the front end and the back end. The Jenkins has direct access to the GitHub repositories. Also, it has direct access to the Ubuntu EC2 server for deployment. Whenever there is an event happen in prod, either a pull request or a merge, we have configured a webhook. This webhook emits an event. This event is captured by Jenkins and the job is triggered. This job initiates the deployment and this deployment runs the script. This script initially builds the Docker image in the deployment server and it stops and removes all containers with the same name. Finally, it starts a new container with a freshly built image mapping the port. What you see here is a build trend, and also what you see here is a build history which happened throughout the project. We have selected New Relic for continuous monitoring. It is a very powerful tool which helps us track the performance, errors, and resource usage of the backend in real time. What you can see here is a web transaction happened in the past few hours. Also, you can monitor the CPU usage of the server, and you can monitor the memory usage of the server. And also, you can get an overall error count has happened in the server, and you can inspect logs. And if you want to debug, this can be done in New Relic. For MongoDB monitoring, we have directly used Atlas. So in Atlas, we can monitor the network, and we have other options too.